All right, it's part 3. Okay, we're back. We are back. So, right, we can now move around, and that's really awesome, right? Move around in all directions. However, we got a problem where my camera is not following my character, so we actually can't move that much. Now, what I could do is pause the game, and I can grab the menu, and I can, the main camera, and I can kind of move it over by just dragging that X value right there, and I can kind of simulate what I would want to see, okay? But we need to write a bit of code. We're going to create a new component on the camera if we want that camera to actually follow our player around. So this is going to be the beginning of what we call our orbit camera, okay? We're going to call this orbit cam. Wait, should we call it that? We're going to duplicate a little bit of code here, but it's not a huge deal. I'm going to call this orbit camera just to kind of get you started, okay? So let's call it orbit camera. And the main objective of this camera, at least right now, is going to be to follow that player as it moves, okay? Later, we're going to have to add more code to our orbit camera script so that when we detect a click and drag, we move the camera to orbit around and look from a different angle, okay? But for now, what we care about is let's go ahead and get a public game object. Let's call this just the target to follow, okay? And then every frame, what I want to do is I want to calculate where is my desired position for my camera, okay? Let's call this desired position, and it's going to be the target to follow dot transform dot position, okay? Remember, we got game object, and then when we want a component on that game object, we do get component, okay, to get that component. But if you happen to want the transform, there's a shorthand, so you can write a little bit less code. That gets us the transform component in particular, and then we can just grab whatever is in that transform. And if you look at the transform, boom, there's the position. So you can do dot position, okay? And now we've got that desired position stored, so we're just going to move ourselves straight to it, okay? All right? So let's go ahead and see what happens. Okay, we got that new value there, so let's drag in the player target, click, and we'll go ahead and play the game and see what happens. Well, nothing. Well, what happened? This is confusing, huh? But if you go to the scene, you can see what the problem is. The map is there, the character's there, but our camera has moved to the exact location of our player target. And so it's inside and below the camera. So that's not what we want. We also want to have an offset, okay? Public vector 3. Cool. So we're going to have an offset, and the desired position is actually going to be our target's position plus the offset, okay? All right. Now, I did the same thing during the last lecture to kind of demonstrate what we want. Let's go ahead and play the game, and it's going to look really nasty again, but then I'm going to change the offset. Let's raise our camera, make that Y go up, up, up. There you go. I want it to go back on the Z-axis, right, out of the screen, okay? And then, oh, that looks really good, doesn't it? We could also do X and Y to be offset, but we don't want that. I'm going to copy this component's value. I need to copy these 3 values because when I end the game, we lose those values. I can paste them back in, though. Let's go paste them back in. Boop, just like that. Okay. Now we can move around. Hopefully, I can go explore the map, and it won't look half bad. Okay? Here we go. All right, we're exploring the map. Not bad, huh? So we're kind of just moving around. We're checking things out. There is the diag, and uh-oh, what's happening? We ran out of space. Well, what's happening here is that the map box, basically, it gave us a chunk of data for where we were. But now, as we move around, we need to kind of get more data, okay? We need to tell Mapbox that it needs to continuously load more data. Now, you can look around for something that will help you set this up. And if you look around, you might say, well, I got a problem with my map. So let's look inside the map. Oh, and there are a bunch of things on this map that I can do. Okay, right? Blah, 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 blah. Image, Mapbox outdoors. You can change how things look if you want. Terrain, Mapbox terrain. Can I change this? Well, I wonder how dark it looks. Oh, that's awesome. Isn't that cool? So outdoors, what about streets? Okay. Satellite. Oh, that's awesome, isn't it? Super cool. I'm going to stick with outdoors. And what I want to do here is we've also got map layers. The extent, right? This is, I think, what controls how much of the map gets loaded in and when things get loaded in. So what I want to do is I want probably not choose camera bounds. If you choose camera bounds, then anything the camera can see should get loaded. However, if the camera ever goes to a low angle and can see far into the distance, that's a huge problem because that will tell Mapbox to load gigabytes of data because you can see very far into the distance. In fact, you can see pretty much all the way across the entire planet. So what I think what we're going to try instead is range around transform. And the player target is the transform we care about. Now, how do I tell it what the... There we go. Visible buffer, so like 5. Okay? Let's see. Yeah. Oh, this is very big. Yep, very big. I think I can change it to 3 or 2, and this is basically creating kind of a radius. Let's see here, around our object. I hope. What I'm wondering is, I hope this will continue to move. That's what I care most about. Okay, so let's put this over here because I want to watch what's going to happen as I move. Okay. So I'm going to start moving to the right. Can I? Oh, I'm moving so slowly. Why am I moving slowly? That's really weird, but I'm actually going to... Oh. Yeah, what happened? Why am I moving so slowly? Let's try this again. Oh, I might be lagging because I've got multiple things here. Yeah, am I lagging? Yeah, I'm lagging a bit. It's not going super fast. Ugh. Okay, watching it. Let's tell the map to go ahead and arrange around the transform. And let's make it like 1. Okay, and hopefully as it moves, we'll see Mapbox kind of loading in more tiles down here. Okay. Oh, it's so annoying how slow it's going. I might actually give it higher speed. Let's do it. Okay, I'm just going to go and make those changes. So range around the transform, give me 1, please. And I'm going to actually make this go a little bit faster. Speed factor is now going to be 2. So double the speed, just like that. Okay, so we're loaded in. We're going a little bit faster, not a ton. Oh, and you see, there you go. It kind of hops around and loads in more tiles as my avatar moves. Okay, so this will be very efficient. We won't have a ton of tiles. Now, you might want to lean the camera down a bit. You'll have to do that with the orbit camera tab later. So I'm actually going to make this into 2. The visible kind of buffer radius is going to be 2 instead of just 1. That'll give us a little bit more space, so we won't see the edges of the map when we lean the camera down. All right, so hey, things are looking okay, aren't they? However, there are still some more things that I'm not super happy about. Okay, so if you look at this, right, look at it closely. Look at how our character moves. It moves in kind of a glitchy fashion, doesn't it? Right? It's not great. And so this is a bit of a bummer. You see, Mapbox will pull down data every once in a while. And this is going to cause the movement to be kind of chippy and choppy, okay? It's not moving every frame. It's moving less often. So one question is, how do you take something that is jittery? How do you take a signal like that? How do you take data that's coming in at a very jittery frame rate or rate, and how do you smooth that over? Well, one classic technique, and you can really use this with just about anything that you want to smooth, is to use some basic interpolation, okay? A lerp, a linear interpolation. This is basically a function that says, hey, wherever you want to go, let's go only half the way there. And then the next frame will go half of the remaining distance. And then the next frame will go even half of that. The result is an object that moves fast at first, but as it closes in on its goal, it slows down. It's moving fast, slows, and then it eventually gets there, right? That smoothness is something we're looking for. So here's what I want to do, okay? This player target moves around automatically right now. What I'm going to do is I'm actually going to make a copy of it, and I'm going to call this the player target view, okay? Now, I'm actually going to get rid of this component and this component, and likewise, let's get our scene view back up here, okay? Right, so we now have a view, which is over here on the right, and we have the actual player target over here on the left. The player target is the thing that's going to move, and it's going to be very jittery, okay? I'm going to take that player target, I'm going to make it invisible, okay? I'm going to actually get rid of all this, and the player target view is now the only thing that I see. I'm going to take this player target view, which doesn't move by default, and I'm going to have it smoothly follow that jittery player target, okay? And if this seems a bit odd, think of it like this. We have found a way to separate the actual underlying data of where our character is from the view of that data. If you've ever heard of the MVC pattern, it's the idea that you've got some data, but you've got many different ways you might want to show it or view it, okay? Another way you can think of this is that you've got a player character, but it's invisible. The player target view is the costume that we see, okay? It's the actual visible thing that represents the player target. Okay, so anyway, let's go ahead and create a script. Let's call this follow target. It's going to be very similar, in fact, basically the same as our orbit camera, okay? In fact, look at this, what I'm about to do. Okay, you should not do this, okay? This is bad, okay? There you go, all right? I don't think we need an offset, but that's okay. It's going to start as 0, 0, 0 anyway. What we do need, right, is some way to say, hey, I only want to move not all the way to my desired position, but I want to move like half of the way, or 60% of the way, or 70% of the way, okay? So I'm going to create a new variable. I'm going to call this the ease factor, and by default, I'm going to set it to 0.1. Okay, and not 2. Let's do that. Okay, now what I'm going to do is instead of warping us to the desired position, I'm going to go vector3.lerp. Okay, linear interpolation between 2 points. I want to lerp between my current position, okay, and that desired position, and I only want to step half of the way there. Or more realistically, right? I don't want to hard code this. I want to step ease factor of the way there. So this is going to come out, at least at first, to 20%. We are getting the point that lies 20% of the way between our current position and our next position. Why would we do that? Well, what you're going to see is that we get very smooth movement when we do this. Okay, it's very nice. Let's hook this up. So our view has a follow target component that is going to follow that player target. And it has no offset and ease factor of 0.2, so it's going to be kind of sluggish as it follows around that character. Hopefully very smooth.